Yeah, I couldn't sleep last night, so I spent a little bit of time on Twitter. So I think what happened here is we canceled the previous work. So it's turned up for a lot more mass than this year. Yeah. Seems like everybody would be.
This is good.
You said you were already dinners. Are you cold? Goes up to pretty. This is not nearly as I thought you were all trying
Let's see if anyone.
Yeah.
These on? 1, 2, 6. Hello, everyone, and welcome to Seoul. This is IPPM. If you're here for the air conditioning, enjoy. If you're here for IPPM, we're going to get started in a minute. We actually, for the first time in a very, very long time, do not have a completely jam-packed agenda, so we can be a little bit leisurely about it. Probably all of the people who have lightning talks are actually going to get to talk this time, which hasn't happened in a little while. But we should go ahead and get started. I'm Brian Trammell, co-chair. Bill Cervani cannot be here today. It's not in Seoul. Already did the IPPM thing. This is an IETF working group. The note well applies. Pretty much anything you say here is an IETF contribution subject to IPR rules under RFC 5378 and 3979, updated by 4879. It's Monday, so we usually don't have a Monday, so I can't make that. You probably haven't seen this. I mean, like some of you might be jet lagged, and this might actually be the first time you're seeing this. So read, understand, enjoy. We got some working group drafts. So IETF IPPM 6-man PDM option is done. It's on its way to, it has not yet gone to IESG balloting, correct, Spencer? It's still in director reviews.
We have no audio.
Huh? We have no audio? Can somebody, okay, there's nobody on Meet Echo anyway. Oh, maybe his audio went. But you can hear, I mean, like I'm hearing me, I'm amplified. Okay.
Oh, does this work? Yeah. So feel free to check this in the data tracker, but I believe this is the one that's added to a telechat agenda after the meeting.
Oh, this one is on. This is on the.
I think you have one of those.
I have one of those, but that's model-based metrics, isn't it?
No, model-based metrics went back to you.
Oh, right. Okay. Yeah. Good. So yes, this one is on the.
This is why we have these conversations.
So we had a big long back and forth. Well, by we I mean the authors. Had a big long back and forth with the security director reviewer about whether or not you could actually put measurement information on an IPv6 destination option outside of ESP. Nalini, please step up and correct me if I say anything wrong here. Then there was a second question as to whether or not you should actually be putting anything on in a destination option at all that things along the path are going to look at, because no, you're not supposed to do that. We wrote it in RFC. And I think at this point, everything is basically addressed, but as part of the addressing, we had to write in must not stick a DO outside the ESP. So you can't use this for doing timing measurements on an IPsec tunnel or IPsec transport mode, but there's not much of that deployed.
Yeah, we have. Yeah. As I say, I need to go back and look exactly at the write-up. There were quite a few actually super excellent comments. Mm-hmm. Yeah, really good. So we're doing. Yeah. So as I say, I actually think that we have agreement between the reviewer mm-hmm. and the authors. I mean, it's shocking, but
that's what it looked like to me too.
Yeah, there's a few things. I mean, as I say, but we're still writing it up because it's tricky. It's tricky how to write it up, and we're also. I mean, there's super excellent comments. You know, I mean, I would like to give Taro a great big hug if he's around. I mean, totally good. Yeah. And because we're going to redo if we do the time base, yep. Then we can actually get some reserved bits or something, which will be super nice. But as I say, we're writing that up, and then exactly how the timing, potential timing attacks. I mean, if I can give the analogy, it's like we're giving people a very sharp knife, and you know, we need to let them know that you could cut your toe off with it. And
so.
Yeah.
So you're also changing some of the timing, like you're actually changing the wire formats a bit, Nalini?
Correct, because the time base, because of Taro's comments, we went.
Right. Okay.
Yeah.
Can you pull that back off the telechat agenda then, Spencer? Because that should actually be in revised ID needed if they're doing a revision.
You see where it is.
Yeah. Okay.
And then I'll put it in the right place.
Okay. Perfect.
is why we have these conversations. right?
Yes.
Yeah, it's just, I mean, as I say, well, it's not, we'll just reserve the bits.
Yep.
But, you know, yeah.
But it changes the meaning of those other bits, so that should probably be what the IESG reviews.
Correct.
Good. Okay.
Yeah.
Is there anything else to say on this one that I didn't bring up?
I think not. No, I mean, we have to describe the potential timing attacks,
Yep.
redo time base, talk about ESP and how it's handled. Oh, I know what. The one last thing, the Gen Art reviewer said that it was a wordy. It is. It
Just
got
delete half the words. Just every other.
so it needs to some
Yep,
cleanup.
another edit pass. Okay.
Cleanup.
Okay.
Yeah.
End of the year.
Sure.
Okay.
Sure. Thank you. Yeah, that's
Good.
great. Thank you.
Yeah. So Spencer, you get that? We'll put it in revised ID needed, and then blue sheets.
What I would do, since I'm playing with the agenda dates anyway,
Yep.
is to put it on another one.
Okay.
Are you
Good.
guys thinking like 1 out or 2 out or
Like maybe 3 out.
3 out? Done.
They're gonna do it. They're gonna do an edit pass. So good. Done. Next. Al, is there anything to say about this one? We're waiting on 6-man. We're still waiting on 6-man for
Yes.
2230 IPv6. Good. So I actually managed to get this one banged out. I think in an airport lounge somewhere. So IETF IPVM model-based metrics 08 has been submitted to the IESG for publication and then kicked back to us by the AD. Because he also did some reading on the airplane. So there'll need to be a revision. It's I've taken a look at it as Shepard. I'm like, okay, authors go do it, which I guess means probably you, Al.
I'm on it.
Okay, good. And then IETF IPVM TUMP time format. Both of these basically sort of sailed through working group last call since Berlin. And then both Bill and I sat on them for a while. So we actually got I got the write-up out for this one. Bill will get the write-up out for that one soon. And then we'll send those up. Here's our agenda today. You are here in Notewell agenda and status. We are way ahead of time. Next we have Klaus Niemanen. I hope I'm saying that correctly. Talking about network neutrality measurement at BEREC. This is sort of a follow-on for Ahmed Abadal's talk last time. So getting into a little bit more details of the types of measurement that they're doing. This is not backed by an individual draft yet, but it will be by Chicago. So you have text, it just needs to get put into the right format. Okay, good.
You have my slides?
I have the slides, I'll put them up in just a second.
Yep.
And then we have Al talking about like many slide decks for the metric registry stuff and enough time to get through them. Altmark, 2amp Yang we're not talking about because they weren't able to get an update in. So we'll talk about that again in Chicago. So we'll skip over that, go to the TMARC reflected registered port, and then we have 2 lightning talks on the queue after that. So with that, those are your slides, right?
Okay, good afternoon. Yeah, I'm Klaus Nieminen, and why I'm here is the European regulators are now required to start supervising and enforcing the new open internet regulation. And we are within the European regulator group, BEREC. We are now trying to specify the tools and the recommendations on how to do so. And I'm leading the one of the work items that is tasked to specify the net neutrality regulatory assessment toolkit. So we are really targeting for the tools and the recommendations. And well, still a few words about the background. Well, yes, as I said, we are going to submit a internet draft with the title you just saw in the last slide. We are really happy to get the draft also broader, basically that it could be made more global, not just the European approach. if there are interest. And yes, it's a contribution from a few European regulators. It's not this kind of the formal BEREC submission, just to note that. Okay, we can go further. So to wrap up, the new open internet regulation is known also as the Telecommunications Single Market Regulation, consisting the roaming and net neutrality. And there's a link if you are interested to read it. Yeah, it came into force last April, and we just published the guidelines for implementation of that regulation a few months ago. And now we're just starting the supervision work. Well, in the key principle of the regulation is to protect the end user rights for distributing, basically accessing and distributing content and information, and use and provide services and applications. So it's not only for the consumers, so only for using the services, but also providing them. And of course, it protects also the right to use the terminal equipment. We can go to the next slide, because that's trying to explain the impact for the networks and ISPs. The basic rule in this regulation is that the ISPs must treat all traffic equally. All traffic equally. I think that's really important to emphasize. Well, basically, there are a few exceptions. So the ISPs can provide better quality if there are traffic classes or this kind of the specialized services that require optimization, or if there's, for example, law requiring that. Also regarding the other traffic management practices, the ISPs can't block, hinder, try to discriminate some certain traffic. Or they can do it, of course, if there's an exception. Basically, if the law requires it, there's a really valid security requirement, or there's also the exception for the exceptional congestion. And this cannot be agreed otherwise. Basically, that the ISP can't put any more this kind of the restrictions to their contract conditions and implement them in the network based on that. So this really changes the business in EU countries. And well, now I'm actually going to the measurement use cases. So we are hoping from the IETF, of course, a larger audience and the better tools to make this supervision work, and also some best current practices how to make those measurements in real life. And basically, if you go to the next slide, I have 3 different measurement use cases explained in these slides. Of course, there are much more, but I didn't have that much time to start explaining all what we have been talking within BEREC. So first of all, there's a new definition on the speeds, and the ISPs for the fixed subscriptions, they have to specify minimum, normally available, maximum, and advertised speeds. And well, we have defined further in the guidelines that the speed have to be defined and measured on IP packet payload level, and it have to be measured outside the ISP's network, basically some well-connected point, for example, internet exchange point. So it's not anymore internal to the ISP itself, the speed promise. Oh, well, the speed itself, that it's not that hard to measure. However, there's a few different things there also regarding this, especially the end user environment and how to detect this kind of the behaviors that could impact the measurement results. And we, of course, try to avoid the false positives. But it's not only making one measurement. How do you measure the maximum speed? Basically, that's a speed that's available at least, for example, once a day. Or the normally available speed, that is a speed that's basically available most of the time when a user is accessing the service. The regulators can make further requirements based on this. But, well, as you can see, it could be something like the speed should be available 95% of the day. And we know that this kind of the long-standing measurements, they are quite a headache, especially if we are targeting for crowdsourcing and end users making those measurements by themselves. So yeah, there's some work to do also regarding the speeds. I'm not talking about the delay and packet loss. They are a bit more trivial. But then we can go to the other network neutrality measurements, we see a bit more tricky. Well, this is one of the topics, at least I consider to be a bit harder target. So if we need to detect the ISP throttling, for example, some certain services, or prioritizing their own or affiliate services. Let's say the ISP prioritize their own web traffic, or they are prioritizing Facebook, or they are throttling some competing services. Basically, that's a bit more harder to detect, and it's not probably only one measurement we have to make. It's combining maybe the normal performance measurements and the application performance measurements, and then doing the assessment. And well, as I mentioned, the one of the problems is really how we can detect the impact of the end user environment, that it's not responsibility for the ISP. The cross traffic, NATs, use of VLAN, all that stuff. And then the last use case I'm having is really regarding the other restrictions. If an ISP is, well, you can quite easily measure if an ISP is blocking certain communication ports, or maybe some web addresses. But then we are going to the details, ISP blocking certain services. Well, we may go to the more passive or hybrid measurements. So I see that, well, we probably need this kind of the both active, passive, and hybrid measurements to actually have these tools usable. And the other thing is that the ISPs, they can't monitor the specific content. According to the guidelines, that means that the ISPs can monitor the IP packet headers and the, for example, TCP headers, but they can't go deeper to the packets if there's no exception. Basically, of course, for the security reasons, you can do it. But there's a lot of these kind of things the regulators need to supervise. And we are really hoping to get tools to make this work done. We are, of course, doing the specification work by ourselves, but we thought that well, IETF would be a perfect place to get the larger audience and review and some proposals, definitely. And we are really open for any comments and your contributions, because you know, at least some of these topics are a bit tricky. So I think I'm finished. There's just my email address in the last slide if you are interested to comment.
So there's obviously been work done outside the IETF, like Nettleiser. I'm sorry, Henning Schutzmanning. There's been work done outside the IETF a number of years ago, 5 years ago at least now, like on Nettleiser and similar type of tools. So do you see that in pretty much, the same spirit? And like would be a tool that would be installed on contributing volunteers, or do you see installing like an LMAP infrastructure, just to take an IETF model, like an Atlas type system, if you take another model, in that, how much, or crudely speaking, how much money do you have to actually, or do regulators have to deploy the infrastructure?
Basically, we are probably targeting for crowdsourcing and the LMAP type of the infrastructure. There are probably some measurements we want to make ourselves, but we are not mainly target. I mean, it could be implemented using probes or the software. We are not restricting the implementation.
Okay, because the other challenge that you have is for some of these applications, like application blocking, depending on if they violate the "you shall not peek" when prohibition in terms of deep packet inspection, knowing you would have to basically rely on users to tell you, I suspect that whatever Skype, just to take an old example, which used to be a popular blocking target for voice over IP, fearing carriers, my Skype isn't working, and this is do check it out, but you can't really do that using LMAP or whatever because the pattern is too complex generally to directly, unless it's just they do crude port level blocking.
Yeah, I know that some of these measurements are quite complex, and we of course now seeing what's feasible and what's not. And of course, some of these topics we can also rely on the of course the end user complaints. Or we don't necessarily have to measure everything by ourselves. For example, detecting if the Skype is blocked, it could be a bit more trivial just using the application from the subscription than measuring it from the regulator point of view.
And the third and final, I get off the microphone cue here, is one of the hard parts, as you know, then when we at the FCC try to do measurements for performance, not so much for that, is not just the temporal variation, but the geographic variation. So we often found that for the same provider, even because of different infrastructure age and a bunch of other factors, some were really good and some were really not so great. And that means you have to have a good geographic distribution, not just
That really depends on the assessment use case we are having. Basically, of course, if we want to have the assessment on market level, then we have to have the geographical coverage. But then we are certifying a monitoring mechanism to check if the subscription meet the contract conditions, then it's okay to just measure that particular subscription.
Okay, thank you.
Hi, Klaus. Al Morton. Welcome back to the IETF. I met you in Buenos Aires. Could you go to slide 3 there, Brian, please? Maybe. Yes, that's the one. So it looks like one of the most efficient definitions of all traffic here would be all user traffic. Is that what you're thinking? Because there's lots of types of traffic, especially the internal stuff that we have to use for network management and routing.
Well, basically the regulation says all traffic, but there's the exceptions for categories of traffic. And I can, for example, understand that the ISP defines network management traffic as one of the categories. So then there can be, for example, different handling. And I mean, the basic requirement is that there's
well, that's what we were just talking about.
Yeah.
That's what I just...
If there's an objective requirement to provide the better quality or more reliability, then you can do it. I mean, it's really about the, for example, yes, the network management traffic is a good candidate.
Yeah.
Because the categories of traffic that involves all traffic belonging to the same category. And the specialized services, there are more conditions how you can provide them, but they can be a single applications, not, for example, all web applications.
And then on the next slide 4, I think it is. Yeah. So you guys have published a methodology for speed measurement?
Yeah, well, we are now targeting to define, our own, at least the best practices, and we are targeting for a tool. So we have a separate stream now for the implementation part.
Okay. Okay. But I mean, if you measure at the IP layer, and I think that's the right thing to do, then you've really got to talk about how the user or how the tool is trying to make use of the network bandwidth, and whether that's a reasonable representation of it. And I don't see a clear. Maybe you're going to ask every ISP to give their speed specification according to this template. And if that's true, it's actually going to be difficult for ISPs, I think, to characterize and figure out, how they're doing, let alone how the regulators are doing, how the regulator would view their compliance. So it's I think this is going to be a challenging set of measurements for the ISPs to respond to.
Yeah, it's actually something that if an NRA is certifying a tool, that basically applies to all ISPs. So, the ISPs have to give their speed promise in a sense that they actually take that into account. I mean, one of the main problems has been the definition of speed, IP packet payload. I mean, if you are having the 100 megabit connection, that's normally the Ethernet level speed, and they now actually, at least in Finland, are over provisioning the subscriptions.
Well, but one of the issues there is it speed that's achieved with a congestion aware protocol? And no one here would want you to say, we don't want protocols to be non-congestion aware in the future. We want, just send and pray. I mean, I think that's the way to waste a lot of packets in the network and a lot of network resources. So there's got to be some interaction here between reacting to network congestion and
yeah, I
the
mean,
speed that results from that.
We could, for example, use TCP, or I mean, it's now under the discussion what kind of methodology we are going to use for the measurement.
Well,
Al, do you want to say model-based metrics, or shall I?
that's where I'm going. That's right. We don't have that talk scheduled today, but we can certainly talk about that class. Model-based metrics tries to avoid the problems with the TCP flow control loop, which makes it so difficult to measure. And as Spencer has rightly pointed out, the 3 pages of motivation should be right in the front where we talk about all those problems. So we can talk about that further, but yeah, model-based metrics, give that a try.
Yeah, I heard that also before, so we are definitely thinking about that.
Vinayak Hegde, ArrayNet Systems. I was involved in the net neutrality debate that happened in India, and one of the problems that we faced was where does congestion and traffic shaping stop and speed promise kind of come in, right? Because you can prioritize certain protocols over others. I mean, there are IETF protocols that allow that to happen. So that's question one. Second question is, we had a problem with free basics, right? Which tries to do some amount of zero rating. Now, the thing is, it can only happen when there are certain middle boxes on a certain path. So how do you kind of take care of that? Because only the speed is limited or zero rated if it goes through a certain path and intermediary, and your deployment should kind of take care of that. Third question is, how do you differentiate between normal measurement, normal speed as compared to normal variations in the network due to multiple users actually using the same kind of infrastructure. Especially when you do end user measurements, this can be an issue. Especially in certain countries where the infrastructure is actually shared, even though the rating is much higher, right? So you might have 100 Mbps traffic and there might be 20 consumers, but the uplink might just be 1 Gbps. So most of the time people do get, but there are times when at peak hours when there might be conflict. So it's little tricky because you have to differentiate between all of these different cases.
Well, first of all, we have some ideas. We don't have ready solutions yet. So I was really coming to here to talk about the use cases and the problems we are facing. Regarding if you have multiple users using the network same time, I mean, that's the ISP's problem in our opinion. Basically, the ISP have to give the speed promise that they can deliver. And I mean, if you are now checking if the subscription meet the contract conditions, if the ISP can't meet the minimum or normally available speeds, so they may be an error. So the ISP have to dimension their network and define the speed values. They can really deliver that. So we are not really, measuring that if there are now, for example, in a cable modem network, too many users, so there's too much congestion. We are not, that's not our main purpose. With the certified tool. Of course, we are tracking in the market level assessment, the overall development, and there are also some requirements that for example, providing the priority for their own entertainment service, that's maybe possible. That doesn't impact the internet access service for the other end users. So it's really, there are many different things. This is really an overview, and if we go to split those use cases, so there are many, many more.
Also, the last comment, the very definition of net neutrality actually varies from country to country. Like if you look at the US, the FCC has slightly different definition. In India, we have a slightly different definition. I have not read what the EU defines as net neutrality. But even in academia as well as in technical circles, there is still a lot of debate. So I think the first thing to nail down would be what is the problem statement to look at.
Yeah, I'm actually targeting for different measurement use cases, or if the different NRAs or the regulators need to measure different things, I see no problem, or there's different rules, because they can all define their own measurement use case and then start finding the tools for the supervision. So I think it's not maybe the right place to start defining what net neutrality means in IETF.
No. No, the thing is, the reason I pointed that out is because it's a little bit of a moving target. That's what I wanted to say. Thanks.
Which makes metric definition challenging. But
Yeah, but we are now targeting for really the use cases, and then we are.
and then you can build it on top of the use cases.
Yeah.
Okay, good.
Frank Bruckner, I also have two questions. So first one, and that's mostly a question on whether you share the same concern. So you're offering, or you're going to go offer a tool or using a tool. That tool will send traffic that has a fingerprint, right? What about if operators would classify the traffic with that fingerprint as management traffic? Correct. So that you have the same situation that you have today with people going to speedtest.com, where you have stellar speed going to speedtest.com, but your internet line sucks. And you would still be saying, well, it's management traffic, hence I can go and classify that differently. So is that a concern? That's mostly my question.
Yeah, well, basically, if, for example, we are talking about the speed test traffic for the regulator tool, I would say that it cannot be classified as a traffic management. I mean, basically the network management traffic. And if the ISP starts prioritizing a certain tool the regulator is offering, I think that's a clear violation against the regulation. And I mean, it's not the only, we don't necessarily have to measure everything. There are, of course, other information sources, and we can intervene. So let's see what the measurements tool can do. I mean, we hope to get the good tools that provide accurate, the enough accuracy, and we don't try to avoid the false positives as much as possible also, so we don't start investigating in vain something that's not ISP's fault.
If there would be kind of legal obligations so that this thing must not happen. And my second question is the tool going to be the only way for end users to go and complain and moan, or are you actually, as part of the overall setup, planning for something where an end user can offer, well, his problem to, I don't know, right? So is there going to be
Can you accept
a way
measurements
to
from
go
things other than your
complaining rather than, or provide active feedback as opposed to you always have to go and rely on a tool?
The setup is different in different countries, but basically, for example, in Finland, the end users can do whatever measurements they like and go to the authority responsible for making that assessment. Okay. So it's not that they have to always use, for example, tool provided by us.
Thank you.
Yeah, cool. So I'm going to cut the line after Jason, and please keep it short because we're 3 minutes behind now from being 15 minutes ahead.
Barbara Stark. So when you were talking about the guarantees and the ISPs providing guarantees to every single user, are you expecting that you're going to collect measurements on a constant basis from every single user so that you can ensure the guarantees are met for every single user?
Well, the answer is probably no. I mean that we can provide, for example, crowdsourcing tool, and users can make measurements, then they see it's necessary for them, or they want to check their own speed. I mean, we are not probably targeting that every subscriber is making constant measurements every day. No, I think that's not our target. But I mean, we are still discussing the tool, and it's of course up on the regulators to decide how they want to use that tool. So we are not probably restricting of course, there's some issues, of course, when it's generating a lot of traffic that have to be taken into account. But I mean, we are now just trying to get tools, not specifying their use here that much.
So during times of congestion, would it be okay to discriminate against measurement traffic? Because that is user traffic, and so shouldn't measurement traffic be considered equal with all other traffic?
No, I mean, the congestion exception, it's really this kind of the exceptional.
Okay.
So it's not the normal congestion there. You can start doing things.
So actually, I had a clarification question about that too. So exceptional congestion really is we lost some links.
Yeah, maybe something like that.
You know, so we're on a tertiary backup, and you know we're putting the entire town on satellite or whatever, as opposed to it's Tuesday at 8 p.m.
Yeah, it's not that it's evening. That's not the valid justification.
Yeah.
So Henning Schutzmann again. I mean, just comment question, I guess, as well is, I know it's attractive to worry about the corner cases, but generally speaking, and at least so far from what I can tell, is things just don't happen. Carriers generally don't lie, because that's usually a good way to get into trouble. And usually somebody will spill the beans somehow. And so when people leave, they get fired, and they're consumers too. So that usually, not saying it's never a problem, it's usually only a problem for really shady operators that operate at small scale and run money. So not your typical large one. And secondly is almost all potential network neutrality violations are motivated not by some obscure type of hide and seek game, but usually there's money there. So it's usually, as you indicated, because there's an incentive to do that, favor your own applications, do zero rating in certain ways and all of that. So you don't have to look too hard, because you know where there's an economic motivation. Again, why spend engineering resources on something that doesn't add any value? Carriers don't do that typically.
Yeah, I was mentioning that we don't necessarily have to measure everything, but we probably want to have tools at least for some of these use cases.
But, and the third one, and this goes to some of the comment, is that in many cases you can rely on the fact, particularly for either non-neutrality type issues as well as performance, when users are unhappy, as long as they have access to good tools that are easy to use and give actually a reasonable, then you can rely on unhappy users if there is a problem. And if there's a 5% problem which nobody notices, well, maybe it's not the world's largest problem we need to solve. It's when people are unhappy with the service because they thought they bought a 100 megabit service, but it really feels slow. Somebody will find it, will complain, and you can offer them a tool to solve that.
Yeah, well, the end users definitely want to have the speed measurement tool and quality measurement tool. Then we are talking about the other violations for the net neutrality. I mean, there are probably some tools we want to have. I mean, for example, I made already a survey for our ISPs, and I have a lot of information what they are doing in their network. Some of that, it's not legal. So yeah, basically we can of course also ask from the operators, but do we want to rely on that they tell us what they are really doing? So yeah.
Jason Weil, unaffiliated this week. On the last slide, just clarification on the monitoring aspect. You're not. You're not saying that you don't want ISPs to monitor traffic. You're saying you don't want them to single out traffic and then take action on it, right?
Yeah, well, basically the regulation says that the ISPs can't monitor the specific content, and now it's further defined by the BEREC. They can rely on the information in the IP headers and the, for example, TCP or UDP headers. But yeah, I mean, we don't have there any this kind of the decisions, at least I don't know any decisions regarding this topic. I mean, that's have to be evaluated and checked case by case. Then there's some suspected violation. But the basic rule is clear that, well, the ISP, with the normal traffic management, they can't go beyond that.
Okay, but they can trend and characterize traffic for capacity planning purposes.
I mean, the capacity planning, that's not a valid exception. I mean, the regulation is pretty strict on many things.
Right, but I mean, they can use IP headers to do capacity.
Yeah,
planning.
they can use IP headers and
Yeah.
layer 4 headers.
Yeah,
Thanks.
but not the layer 7 stuff.
There's actually one
Yeah,
remote
it was-
participant in
It
queue.
was after I closed the line, but why not? Yeah.
Okay, but I
But-
think there's a lot of interest at
Yeah,
least.
but there's one more from, you can't really see him, but Ignacio, can you hear us?
Yes, yes. Can
And we can hear you, good. Yes.
Okay, okay. Well, good afternoon. I am from Buenos Aires. This is night. Here there is a full moon here, therefore it's quite difficult, but no problem. Well, I would like to ask if all these tools or some of them are already developed or you are developing there, because there are so much problems, some problems, I mean, about if you are measuring speed, for instance, and you are trying to saturate the link, okay, this includes a lot of traffic inside the network, and well, perhaps you can, there are some other ideas using less traffic. How about the developing tools, or how about is the state of the tools that you are considering for this work?
Well, we're just starting to develop a reference implementation, and they have to make their different decision if we are really implementing a common opt-in tool for all European regulators. So we're just starting.
Okay, okay, this is very starting point. Yes.
Yep. Thank you very much. So I hope this was interesting and useful for everyone. I mean, it took a while, so it seemed to have been. So now, 12 minutes late, we have the Al Morton Show. And is this the one you want to start with, Al?
Yes. Yeah.
Good.
They're all jammed together.
Right, yeah.
So, thank you. And you're going to do the
Yeah, I'm going to do the
right?
thing because, yeah.
All right. So first off, I made a mistake on this slide. It's actually 09. Where I revved this twice since the last time we talked, and I'm still Al Morton. All right, that goes that way. All right. So quick overview of the registry concept. The problem is that we have specified a lot of metrics here, but we've left a lot of flexibility in the metrics when we did that. We left a lot of input factors as free variables. What that basically means is that you can have two measurements that comply with IPPM's RFCs, but they don't measure the same thing. Even if they're, and they could be applying to one RFC. So what we've done here is to try to take a step up, and in the registry, we nail down a lot of the variables to specific values. And that way, we're more likely to get comparable measurements when I say I've made round trip delay number 1 and Stuart says he's made that same measurement. And if we've done it over equivalent paths, we should get the same numbers. So that's the step up that we're trying to do here. So let's see. Then the other quick thing is here's the registry concept. Each registry entry is going to be a row. But we've organized them into columns, and I mean the rows are organized into columns, but also categories. So and you'll see that better on the next slide. Let's see, anything more important here to say? I'll just let you stare at that while I read it. Oh yeah, so what we're planning to do is on the IANA site make a simple summary of the registry entry available. It'll have these kinds of information there with the rows indexed by IDs, the 16-bit identifier, a metric name, but most importantly, a URL to the template, which is a complicated specification for the metric registry entry. And that would look horrible in a table on a web page. It would be almost unusable. So this is the compromise we've made, and we're trying to make the registry entries as usable as possible. On down to the next. So here's, for the first time in a long time, the revised categories and columns that we're going to have in the registry. And most of the feedback on this that caused the changes is from two places. It was from the IPPM meeting last time. That's down here in the output category, the calibration column there. And then up in the summary, we've added a new a couple of columns there. The change control, who's responsible for sort of approving a change here if we want to revise a metric entry. That's the change controller. And then if we allow extensions to the registry, we should have a version number for this particular format. And so we've got that now too. Okay. I'll quickly point out that there's a metric definition and a method of measurement. And with the metric definition, there we have the fixed values for parameters that would tend to narrow down how the measurement is conducted. So, for example, the packet stream on which the measurements are being conducted, that would typically appear in the fixed parameters. But you have to leave some things available for modification. The best examples are the source and destination addresses. So the runtime parameters are a place to put those kinds of things. And if you want additional flexibility in the metric entry, you would put more things in the runtime column and move them out of the fixed parameters. There's always going to be interaction between those two, depending upon how much specificity you want or how much runtime flexibility. Okay. You're doing well following me. Yes.
No, I'm not. You haven't been checking.
Okay. So let's see. I think I'm on 5 now. So here's some more about the registry draft updates. And the naming has been an interesting exercise for the metrics, and I think well, I'll just say that we've got a part of the naming elements which is called the subtype method, and you can have as many of these subtypes: ICMP, IP, DSCP with a decimal behind it, and UDP, TCP, Poisson, periodic. You can have as many of those as you want that apply to your metric. And we've worked it out where these are now going to be separated from each other by a hyphen instead of an underscore. So you can actually see this one section of the name that can grow or contract. But you'll always know because of the hyphens that this is still one element, and it's the subtype method. So we'll see some examples of that in a minute. Next slide. So more updates. Feedback from, actually a lot of feedback from Michelle this time around, Michelle Cotton from IANA. We got together in Berlin and talked this out face to face. And one of the last questions Michelle raised was, you've got this URN here, and it's kind of a subspace of the parameter. I mean, IPPM and metric, that would have been new elements there, but it was thought to be appropriate to put this in the parameter namespace. And I looked at this and said, well, wait a minute, parameters are for protocols. This isn't a protocol. This is a metric registry. We're just talking about metrics here. So what I've proposed, and I've proposed to all of you again now, is that we try to get a new namespace for metrics and make it simple, and then the names will simply follow from that. So that may be a big deal. I was a little bit afraid to go down this route, but then I said, well, give it a try. So
Make it very clear that I'm not doing this. Sure.
Okay.
Brian Trammell, individual person off the street. I think that's not specific enough.
Okay.
I mean, there's a whole bunch of other things that could go under a metric space under IETF. So this is like so this metric registry, you could, I mean, we went back and forth on this, and this was like the entire giant, I think this was like 1.5 meeting cycles that took us to get to the end of this. And I actually forget where we got. With respect to the interplay between this and the PM Deer 6930, I forget that. So there's the template for a metric. Performance metric
yes,
definition.
yes, yeah.
There are other metrics other than performance metrics.
Right.
And it's not clear to me that we want like a single namespace for all performance metrics in the IETF, because we did actually say that you could use this registry to do things like the XOR block metrics.
Right, right.
But maybe you don't necessarily want to force that to happen. So I would scope it a little bit tighter than this. So it doesn't need to be you're an IETF param IPPM metric, but maybe you're an IETF metric perf, or just it's otherwise it just feels to me like we're jumping on a namespace because we were the first ones that got there.
Okay.
And this is not DNS op.
And but I think, all right. Well.
I mean NIT, but
yeah. No, I appreciate that feedback. So metric performance perf as it needs another level. All right.
sorry, Michelle.
No, it's no.
Okay.
Right. So we'd be specifying then two things: metric and the further subspace.
Yeah.
Okay. Cool. All right. So thanks to more help from Michelle, we've got an expanded IANA section now. I mentioned we have these 7 columns. That's the summary, and that's what's going to appear in the on the IANA page, and then and that'll link to the template, which is HTMLized, just like the internet drafts, so that you can easily use the references and stuff. I think that'll be a big help to readers. So 2 forms of extension, and why we have the version field now. Along the way, people could propose new categories, and they could also propose typically new columns if they're going to do that, but also just columns to be added, just like I just did it in a couple of cases. So that would be one form of extension, and if you did that, you'd have to bump the version number, and that actually makes it easy because now we don't have to go back and look at all the existing registry entries and say, okay, for this registry entry, what would this new column entry be? Well, I think the version number saves us from having to do that. So we'll give that a try. And then the name element sets for all of the things, like the metrics and the subtype methods and the units of measurement and so forth. They're all that's a potential area for expansion. Anytime a new metric comes in that wants to be registered. So I'm actually going to suggest that we have a sub registry for that, I think, but we'll have to work out how that works. What's going on here? All right. So I mentioned the 3 new columns, and the special one is calibration. That was brought up by Ahmed at the last meeting, and he's the Ofcom regulator, and I think we can support calibration testing for some kinds of metrics. It's mostly about characterizing the error and what amount of the precision is going to be sacrificed when you do that. But you could also use this column to report clock offsets when that matters, like from one-way delays and so forth. So I think that there's some good potential uses for the calibration column. So moving on, we're still using the Buenos Aires metric naming scheme, which has all these elements here: metric type, method, subtype method I mentioned quite a bit, the spec that specifies the entry, units, and the output. And there's actually many more examples of these things now. I didn't bother to update this already busy slide. And I mentioned the sub-registry part. So here's the some examples of the names according to the Buenos Aires scheme. And we've got round trip delay. It's an active measurement. And now you can see the subtype. They're IP, UDP, Poisson. So they're separated by the hyphens. And then the rest of it, seconds, 95th percentile, and so forth. So I think when I look at these now, I say, oh, I can tell sort of what this is, and I know where expansion and contraction can take place, and so forth. So, and all these statistics, now there's no percent signs or anything like that. So we've managed to clean this up over time. So it sounds like we got a good comment on the URN today, so I won't go back into that. The one question in my mind, and I actually broached this with Benoit today, do the name element sets cover passive measurements well enough? And you really have to look at the name elements to answer that question. But so that's a little bit of an open question. It would be good if we had some examples of passive measurements. And let's see here. So I'm still suggesting to maintain the name element sets as a part of the draft until done, and then we'll work out how that becomes a sub-registry. I'll probably want to talk to you a little bit about that during this week, Michelle. Okay, thank you. So, so that's the main registry design and what we've changed. At the very end of the talk last time, it's a good thing I went back and listened to the video, or I saw the video. Brian challenged us to write a model-based metrics version of this.
How far have we jumped? Oh,
Just
okay.
one.
You jumped 2 slides without me knowing you were on the slide. So
okay.
Yeah, here's some examples. This is the to-do thing. Yeah. Okay. Good. Got it.
I'm not
Good.
doing a good job of this
Boom.
today. Sorry.
All right. You can say next.
Yeah, I keep forgetting to do that because I've got what looks to me to be complete control here. Sorry about that. All right. So so I went ahead and did one for model-based metrics, which was a little bit challenging, but it's a test of the registry design, and really should be part of the initial registry because this is the metric that all the regulators are asking for. So, or at least some sort of bulk transfer capacity metric, a speed metric. So here's the name, one-way MBM, active IP TCP sustained burst, and the rest of it there, enumerated as the units. And this is a pass, fail, or inconclusive metric. So when you look at this testing, there's going to be set limits that you have to meet, and you'll generally evaluate the round trip time and the loss ratio to tell whether you've met the speed that you're attempting to, the target rate that you're attempting to achieve. So was the registry design efficient? Yeah, because we had a very special section on packet stream generation, and that's one of the most complicated things in the model-based metrics draft. You've got slow start, paced bursts, continuous bit rate. You've got all kinds of things there, and I think that we have the flexibility to cover that. There's also many runtime parameters, and we've got the ability to do that. Additional parameters calculated in the model. I've already mentioned the pass, fail, and inconclusive is the outcome of this metric, but that means that we had to have that. So we actually added quite a few things. It was a good exercise to do this. And there's more to do on this part of the draft. I separated it from the other as a part 2 to keep it logistically simple and to be able to work it with Matt to some degree. But I think the short answer is yes, the design, at least expanded to cover this fairly well. So so the next steps for this are to combine it with part 1 and not keep it around separate, and to add the remaining data formats, which I kind of jumped over because I was running out of time. So then very quickly in the initial performance metrics, this is where all the initial entries live. And these are the ones that we're trying to curate and keep up with the registry as it's changing. That's been difficult to do. And but I think right now sections 4 and 5, which have metrics in them, they're up to date with the changing format, including the IANA comments, so that's good. New sections, new name conventions, they're all in there. And I think we've got to add a loss metric here. We've also got to add trace route, and Ignacio has been relentlessly but also very encouragingly trying to get some more work done on this. He has some ideas on trace route and making some measurements with it. I think we want sort of 2 levels of this. We want a trace route measurement, and then we want the round trip times that come from traceroute as well. So you want to be able to do that those kinds of things. And do we want to ping measurement in the registry? I would say absolutely we do, because it's the simplest one to make. So, right. So next steps, discuss and close any open issues, and you guys get to open issues along with me, and update the other sections that include DNS response time and other sorts of things that we've got in there, a little more complicated active measurements and so forth. So that's it. Any other questions?
So yeah, this is a chair question. And maybe to a couple of people in the room who are also paying attention to LMAP. So one of the reasons we went down this path 2 years ago now was to have a registry that LMAP could use, and LMAP has gone down a separate path of its own, a couple of twists and turns. I mean, like with respect to going and, you know, figuring out the control parameters and stuff, right? Have the contents of this registry had any airing in LMAP yet? Is there do we believe that the people who are participating in LMAP are paying attention here to this? Does this meet the needs that LMAP is? When LMAP comes out and has all the control situation figured out, is this going to be the data registry that they want?
I'll let other people answer that question. I've got an answer,
Okay.
but let's hear from Jason, guest working group chair.
All right. Jason,
Thank you for coming to this one, so I don't have to be an LMAP because I have a conflict.
I mean, I'm personally think it's being written for I mean, they're definitely interchangeable. So we're looking for this to serve that purpose.
And it
Now,
seems
there may
like
be
it's
one or
still
two
doing
members-
that, or
as long as the information model stays in sync with this, I think we're fine.
okay.
Which we'll find out on
Well,
Thursday.
Well,
Okay.
and actually, that's one of the points of contention. The framework, LMAP framework, made it very clear that performance metric registry entries would be a very visible part of the information model.
Right.
And there's now a proposal to just talk about task registries and sort of make, I think,
To get rid of the metric registry and turn it into then sort of like a thing that can be linked to an executable as opposed to some data elements.
yeah.
Okay.
I think that's one interpretation of what's happening. I think I'd rather keep the performance metrics
Great. Okay.
more evident. So
We'll have to have a consensus column.
Okay.
we can't get consensus when there's two people yelling at each other.
Spencer Dawkins, speaking as an individual who read the model-based metrics draft on the plane. So does this map onto that, or is that a framework that still needs more work, or how do you see that?
Well, we did a whole internet draft to show how a model-based metrics.
Okay.
That was the second draft I showed.
Okay.
Maybe I didn't describe it very well, Spencer.
Well, I
If
could
there
be
are-
zoned too, so thank you.
Yeah, let me, if I may, because I think we're about as jet lagged as each other. Let me rephrase Spencer's question, and maybe if not, I'll just ask my own. So you found some things that you wanted to change in the registry because model-based metrics needed, you know, the ability to actually stick stuff in columns in different ways. So there was a
No, nothing like that.
Oh, okay.
No, what I found was, for example, we didn't have a subtype that matched.
You're not changing the structure. You're changing some of the things in these sub-registries. Okay.
That's right. That's right. In fact, we just expanded the sub-registries. Yeah.
Did you find when you did it? Did you find anything in model-based metrics that needed to get fixed? Actually, I think you did. I think you also read model-based metrics once after you started this.
No.
No. Okay.
No.
Okay.
No. Model-based metrics was in.
It was already done. Right.
Yeah.
Okay. Yep. Okay.
Yeah.
Good. Cool. Were those questions that were kind of like the questions you wanted to ask?
They were. You did an excellent job with interpreting. Thank you. So I think at least part of the answer is that these are registries. So I should stop worrying.
Yeah.
Okay. These are registries, so I'll stop worrying. Thanks.
Thank you, Spencer. All right. And we were done, right? We were in backup.
Yeah. That's
Good.
That's it.
Other
Okay.
questions?
So, yeah, if there's questions, please come to the mic. And while you're coming to the mic, it doesn't look like you're coming to the mic.
Okay.
Um,
So Giuseppe, come on up.
please read the draft and, okay, no, come on. Please read the draft and imagine that you would be the implementer who is trying to make this happen and what questions you would have, because that's the feedback we need more of.
And because of how I loaded these, we're going to get to see all of the backup slides. Boom, there we go.
Okay, this is the update for the alternate marking methodology for passive performance monitoring. So 0.2 version. Next slide. First of all, I want to thank for the comments because this gives the opportunity to the authors to make some topics clear and definite. So in this slide, I mentioned the important modification we made from 0.1 version to 0.2 version. In particular, we have a new section regarding timing aspect that address the comment from Chimbu on mailing list and Jose Ignacio in Berlin, but always in Buenos Aires. And the delay variation measurement details. So in the oldest version of this draft address especially the packet loss and delay measurement and just a short paragraph about the delay variation. Now we add more details regarding the delay variation aspect and other editorial changes regarding movement of some statement from some section to implementation and deployment and acknowledgement section in order to make the description of the methodology more general. So the timing aspect, as I mentioned before, the oldest version of our draft talk about the two contributions that affect the alternate marking accuracy separately. Now we put together these two contributions. So the two contributions that affect this kind of metrics are the clock error, of course, between the two measurement points and the out of order at batch boundaries that is strictly related to the delay distribution of our network. So in this new version, we take these two contributions together, and the only hypothesis that we have to do is that each market packet must be assigned to the right batch by each measurement point. Next. So if we consider a batch of packets, a market, and L is the length in terms of time of our period, we define the guard band D that is given by two contributions. A, that is the clock accuracy, and the delay distribution. So the difference between the upper bound of the network delay of our network and the lower bound of our network delay. So the hypothesis is that the available counting interval must be greater than 0. So L minus 2D must be greater than 0. And this is the condition, the requirement that must be satisfied. So the guard band has to be smaller than L divided by 2. So I hope that this treatment of the timing aspect make all the topic clear. Okay, next. Regarding the delay variation measurement, we refer to the definition in RFC 3393. So in this RFC, the IP delay variation is the difference of the delay of two packets between two measurement points, simple definition. So if we refer to the alternatives that we give for the delay measurement, we can consider the three methodology we consider in our draft. Regarding the single marking method, so we take the timestamp for the delay calculation, we take the timestamp of the first and of the last packet of our batch. So for the delay variation is the same. We can consider the variation of the delay between these two packets. For the double marking methodology, we consider the second market packet for the evaluation of the delay. The same for the delay variation. So if we consider the 2-second market packet, we can calculate the delay variation of this second market packet.
Can I ask a clarifying question? That's the second marked packet in each flight of each color, correct? Or is that okay?
Yeah. Have a different color,
Yeah.
so you can identify this packet, and you can. The last one is the mean delay method that, okay, give just a mean value for all the batch length. But you can apply in the same way also the evaluation, but not the evaluation of the delay variation packet by packet, but you can calculate the average delay variation of a batch. Is the same way of thinking of the mean delay. So in mean delay, you have the calculation of the average timestamp. In this case, you can calculate the average delay variation, and you have a simple formula like the mean delay method. Nice. And now we have an update regarding the marking method use cases. In particular, I want to mention the RFC 6374 update. So regarding the packet loss measurement, the topic is unchanged and stable, and more information are added regarding the delay and jitter measurement. So you have the reference of this draft. If you want, you can read also this use case for marking method.
So as one of the authors of that draft,
yeah, of course.
Sorry. One of the pieces of input I would really like to see is just focus down on what set of measurements we need to do, because we put a number in there, but it would be kind of nice and friendly on the hardware, because this is going to have to be done kind of right at the sharp end of the router. It would be nice to just tune that down to just the ones you really need, rather than the sort of the large number we have at the moment. So I think we need to focus on what's really, really needed out of this hardware.
Good. Okay. Thank you. The other use case is in beer working group. So the application of a marking method in beer domain has been adopted as a working group document. So this is the news. And the other use case is the overlay OM. So the work is in progress, and the document that is the reference for this work is the gap analysis document. Next. Okay. So the authors think that document is in a consolidated version. The content could be considered stable. Maybe some editorial changes are needed, but okay. There is the working group plus call for November, I think.
That was the milestone that we had.
Milestone,
yep.
Yeah, on milestone.
This is November. Can I see a show of hands who's read this draft? Is there anybody of the hands that went up that would have a problem with this one going to working group last call? No? Okay. So we'll start that on the list after this meeting.
Okay.
Quick question. Al Morton. Giuseppe, you had the average, the mean delay variation there.
Yeah.
And that's a statistic that's kind of like the least useful when you're measuring variation. You want to have some sort of view of the extent of variation. I mean, it's okay to have the mean delay, but the variation should be characterized by its extent. So maybe
well, but you can do that with the single or double marking methods, right?
Yes, yes.
Yeah, oh yeah.
Yeah.
Yes, yes. This is an
So
The SFL draft proposes to collect things in a bucket arrangement, which is kind of easy to do, or collect a max, min, and mean, or collect variance, because and from variance you can compute standard deviation.
right.
But you need mean as well as variance to do that.
Right. Well, it sounds like you're going to make a parametric assumption there, and I think what you want, I think what you want is a high. I think what you want is a high percentile. In other words, not the max, because that's unstable. 95th percentile and the min. The min's usually stable. Anyway.
Yeah, if you can take that offline and, well, actually take it to the list so that we can see it, so that I can make the working group last call happen after that converges.
Okay. Can I add just a thing?
Yeah.
Now, regarding the mean delay, I want to add that is not an alternative for the mean. It's just give you just the opportunity to calculate the mean delay of a batch without exchange every timestamp of the batch. So you can exchange just the average timestamp. It's just to note that characteristics of marking method, but I know that it's better to know to have maximum, minimum, standard variation, and so on.
So yeah, yeah, good.
It's just a property.
We have a way forward. Thank you very much. And we actually don't have anything on the missing one is Twamp Yang, right? So we'll skip it and we'll go to Greg.
Okay, so this is the title. We can go to the next slide, which is the only informational slide on this presentation. Yeah. Okay, so we have very good discussion after Berlin, and we thank Luis for his review and comments. So he agreed to join in the work on this document. Welcome, Luis, to the offer group. And their current update includes the clarification on what we meant by backward compatibility. The backward compatibility of this proposal meant to be related to their TWAM control case when the server advertises allocated UDP receiver port. So in that case, even if their client doesn't support it, so then will be renegotiated. Okay, and we extended security consideration section because that's very important, of course, and identify the threats is denial of service attack. The recommendation to mitigate this threat is by filtering access to TWAMP receiver port, obviously, and use non-routable IP address for the session. And in the scenario of man in the middle, use the data consistency check and, of course, encryption. So, and we, as always, appreciate your reviews and comments, suggestions, and would like working group to consider adoption of this document.
So I think I'm not going to run an adoption call today because I want to get one out of the, but maybe we can adopt it between now and Chicago.
That will be great. Thank you.
So what I do want to see today is a show of hands, people who've read this one. Oh, we got to get that number up. So Greg, you have homework. Get that number up, and then we can make a call for adoption.
Yes, please. It's not a big document.
Thank you. And now we go to the lightning talks. Yeah, I think this was the first one in line. You're gonna come good. You're Praveen. Or no, you're Sudhin. Yeah, yeah. You can call me Jacob. Okay, good. The floor is yours.
Can we go back to the first slide?
Yeah.
Thank you. Yeah, hi. This is, I mean, this is a generic, we are proposing a generic model.
A little bit closer to the mic. It's, at least for me, it's really loud in the other room.
Okay, is that fine?
Yeah.
Okay. So this is our draft. We are not proposing any protocol. We are just proposing a model to measure the packet. It can be any technology like overlay, underlay, and based on the customers, like based on the customer traffic, you can measure the packet and the color. I mean, if it's exceeding that, we will explain. So can we go to the first slide? Yeah. This is the, these are basic things why we are going for this draft, because the end customer, the providers, they want the SLA driven services, and they don't know, to the end customer, are they delivering the, that committed, how they measure the packet. See, these are the, I'm committing this much PPS for you. How the end customer will know he is delivering me this much amount of packet. So this model explains, and this model helps you to count the packet and give the customer that what is the exact PPS and what is the committed rate. So this draft explains the model so that the end customer can get the data. And we have proposed four different models which can measure the packet and the packet as well as the loss. So one is, can we go third slide? Yeah, these are the models which we propose. One is the complete loss measurement in one direction. So if you have one direction, so if you can measure the overall packets, so if there is any loss, so that can be calculated. And another one is the color-based measurement. That is, if a particular service, if you are offering a service to the customer and they have say the SLA, and are you delivering the SLA? How to find out? So this model explains the SLA, and if they are exceeding that, or if they are exceeding the traffic, that can also be measured with the help of the color-based measurement. And the cost-based measurement for each, because they will have a different, the end customer will have a different application, say voice, data, or the unwanted services. So they segregated the traffic and they measure the packet, and they measure the packet based on the each cost level, independent of the each layer. So earlier, like you measure the overall packet through a pipe. This model explains you to measure each services or the each customer application, the cost based, that count you can get it, and as well as if there is a drop, that can be measured. And cost, and the last model is the cost and the color-based measurement. In like that, it is similar to the previous one, but here you can give the color also, the color like green, yellow, and red. So if that particular application is crossing the limit, so if crossing the limit, so if he is overutilizing, you can charge preferential charging, or like that. The billing can depends upon the usage. So these are the model. Yeah.
All right. Greg Mirsky. I think that their definition of what it means, the threshold, crossing the threshold, it's a very interesting topic, because again, in order to be this state stable and not really fluctuate, you need to have some definition of service degradation defect.
You mean, if it is like exceeding, means if you have a police setup and you have a SLA agreement with the customer, say I am having a X PPS, and if it is exceeding, is that the?
I'm concerned that if you define their service degradation or out of SLA based on a single measurement, then your state will be unstable, and that's a problem. If we look at ITU definition of service degradation, so you need to have a number of consecutive measurements that are above or below of certain threshold.
Yeah, this model, and that's why we are telling this model is you are measuring over a period of time. It's not like one time you measure it, because over the service is running.
No, I'm not talking about that your measurement session.
Mm-hmm.
So you measure certain metrics in your test session, and then you need to have number of test sessions that are out of profile to state Correct. That your service, okay? So it's...
Yep, That's correct. I mean, once this is measured, the history is stored, and he will be getting at, the historical data. So that can give you the overall. It's not like, you are taking for 1 or 2 measurements. It's over a period of time, and the historical data, which can analyze and give you a, good statistical report.
Right,
Does that answer your
think,
question?
yeah, I think that itself, the definition of service degradation is different for different service. So the model should have the model to define this policy.
Got it. Definitely, we'll add it. Done.
Yeah, so you're done? Cool.
Thank you.
All right, thank you very much.
Go back one.
You got 5 minutes and 20 slides, so.
Go back to the, okay. Yeah. And eat the mic here. Okay, so my name is Tal Mizrahi. I'm from Marvell, and this draft is joint work with the people you see here, Giuseppe, Mac, Firo, Greg. And actually, this draft is tightly coupled to the draft we discussed earlier, alternate marking. Okay. So what are we trying to do here? We're trying to measure loss and delay between 2 measurement points, MP1 and MP2. Next, please. And the alternate marking draft proposes to do that using a marking bit, also called a color bit. And the idea is that the color bit basically segregates the traffic into separate blocks. Each block is counted separately by the 2 measurement points, so that each measurement point has its own counter, and then we can compare these 2 counters, and based on that, we can compute the loss. How do we measure delay? Basically, there are 3 possible methods to do that. Next, please. One way to do it is always to take the first packet of each block and then to compare the timestamps measured by the 2 measurement points. Based on that, you can compute the delay. The main drawback here is that if packets are delivered out of order, that means that which packet is the first in the block is not necessarily consistent across the network. Another possible method is to basically timestamp all packets and then measure an average over all these timestamps and compare the average of MP1 to the average of MP2. And the main drawback here is that it's either difficult to implement or computationally more difficult. And finally, a third method, which is also called double marking, it was mentioned earlier, is basically to have an additional bit in the header, which is used for indicating this packet is intended for timestamping. Now, when you have that bit set, you know you need to timestamp that packet. So obviously, this is the cleanest method, but the cost is that you need an additional bit in the header, which you don't always have. So what we're proposing in the current draft is basically a multiplexed marking field. Next, please. And the idea is that we use a single bit which multiplexes the color bit and the timestamp bit into a single bit. And now we can enjoy the benefits of the double marking method using just 1 bit. And the idea is to do a time division multiplexing over that 1 bit. So let's see how that works. Next, please. If we had used 2 bits, it would look something like this. Next, please. What we're proposing is let's use an exclusive OR between the 2 bits. That's going to be the single multiplexed bit. And what it's going to look like is most of the time, the value of this bit is going to be equal to the color bit. But specifically for the packets which are intended for timestamping, the value of this bit is going to be reversed compared to the color in that specific block. So let's see what this means for each of the measurement points, MP1 and MP2. First of all, for MP2, so we're looking at we're focusing on a single block, and we're assuming that the color changes periodically with a period P. And what MP2 needs to do is in the first quarter and the last quarter of the block, MP2 is going to look for a color change. Okay, so it's going to interpret this field as a color indicator. In the middle half of this block, MP2 is going to interpret this field as a timestamp indicator. Okay, so we can see there are two changes in the interpretation of this field, from blue to green and from green to blue. Next, please. So what this means for MP1 is that MP1 is allowed to change the value of the color only during the blue period, and it's allowed to set the timestamp indication only during the green period. That means there needs to be a guard band period between the blue and the green period, which guarantees that even if the two sides are not synchronized, this guard band allows to avoid inconsistencies. Next, please. So what have we done here? We use time division multiplexing to use a single bit to convey actually 2 bits, a color indication and a timestamp indication. And the cost that we have here, what we're paying, is we're requiring the two sides to be synchronized with an accuracy of plus or minus p divided by 8, which is not so bad. Okay, next, please. So this is a new draft. We just recently submitted it, and we're eagerly awaiting for feedback from the working group. And after that, we'll try to go for working group adoption. Thanks.
Thank you. Questions?
Stuart Bryan. So over in MPLS land, I don't think we don't have any bits, so we have to do it with labels. So there's not quite the same sort of issue. And I assume that you're going to do very long sort of delay measurements and lots of these smaller samples in the middle rather than just one as you showed.
Right. So first of all, during the timestamp indication period, you can actually set the timestamp bit multiple times.
Right.
But you need to make sure there's enough gap between them to, again, to avoid these inconsistencies. And to refer to the MPLS question, you can just use 2 label values.
Yes,
and you can use them intermittently.
I know how it would work, but we've probably got a few more label values and lots of counters associated with them. So in some ways, I'd rather not touch the hardware, just set it up for doing the measurements. And
Great. So for the MPLS stuff, you don't need to save bits, I think, the shorter version of that. The bit saved version of that is don't save bits on MPLS because you have a lot of them. But I mean, this would work with sort of like non-MPLS. So remind me in P3M, where do you stick the bits usually?
So it depends, but one of the things that is proposed in the alternate marking draft is to use the DSCP in the IP header.
Which has problems.
In beer, there's a dedicated bit for this.
Okay.
In this other world, we've only got 3 of those bits.
Right. Yeah. Okay.
Yep.
Good. All right. Thank you very much.
Thank you.
Any other business? Going once, going twice. Thank you very much. That was IPPM. I will probably not see you in Chicago. Depends on when they, so I'm only going to be in Chicago for part of the meeting, if at all. So depending on when they schedule this, I may or may not see you guys in Chicago, but I will definitely see you in Prague. Blue sheets, anybody not yet signed them? Blue sheets have been signed by everyone. Excellent, thanks. Gonna be here for 5 minutes to make sure my Thank you.
So that's where let's stop thinking about how far we can reach with different teams. Because it could be very specific what we want to achieve. At the same time, again, there's something not there's cost. Usually they have world-class drones, so their will be
Yeah, there have to be some kind of canaries for that. Great slides for they say very important.
It's waiting.
I think it might be waiting for 80. Then it's for IETF last call. Then we have to call it out for another last call. It just takes a while, yeah. Let me have a look at the history. Yeah, no, it's been through last call. Let's take a look at the data. I don't think I have. Yeah. Let me verify that that's. So when are you going? So I have the DNS over HTTP thing, and I want to go to at least the beginning of that. It starts right after the last thing, so at 6:45. So if we go a little bit later to